Okay, good morning, good morning. We'll go ahead and get started. It's about 11 o'clock, so our session today will be about 45 minutes. So we want to make sure we give our speaker enough time for his presentation. So hopefully you're enjoying Houston's security conference, or HouSecCon. So this is our third presentation today, including our keynote. This morning we will have Mr. Dennis Hurst, and he will be giving his presentation on application security in an Agile SDLC. So I'll let Mr. Hurst go ahead and give his introduction as well. And thank you.
Is that better? Oh yeah, that's good. Good echo. Welcome, thank you. If you guys want to move up, you're welcome to, or if you're in the back, if you have questions as we go through the talk, feel free to raise your hand, holler a question. It's a moderately small group, so we should be able to take questions and get through pretty quickly. The presentation I'm giving today is based on working with customers for about 14 years. I was with SPY Dynamics originally. I was the original author of WebInspect, one of the dynamic scanning tools. And then just working with customers, dealing with how do you get developers to write secure code. A lot of the trouble that I've seen over the years has been more about process and people and less about technology. So if developers used every technology we gave them, we would be in a much, much better place. But how do you do that when you're massively outnumbered? I've got one customer that had 2 AppSec people and 4,000 developers. So, and that's a heavy ratio, but it's not insanely different than what everybody else has. So this was really focusing on how do you deal with security in an agile development process, which compounds some of the things we've had historically. So just as a quick brief, this talk was designed to give to developers and security people, so there may be some things you're familiar with, some things that are new, so a little bit of a switch. So one of the things I always like to talk to developers about that is security traditionally is a very operational type of activity usually. So it's things like I'm operating firewalls, IDSs, IPSs. It's things I'm doing to defend the infrastructure of my company, or a lot of times it's audit-based. So we'll have policies and procedures that developers are supposed to follow, and they may or may not follow those. And then when you get into agile development, we'll talk about why developers tend to not ignore them, but simply don't notice what you're asking them to do. So it's kind of a different thing. When it comes to web applications, RESTful web services, things like that, it kind of reminds me of the show Game of Thrones, if you've ever watched it. There's this part of the storyline is that there's this great northern wall that keeps out the savages up north, and then they punch one hole in the very bottom of it to let everybody through to go do whatever they need to do. It's kind of like we deal with websites, right? You build this beautiful firewall and then punch a big hole. And guess what? The bad guys come through the hole. So that's where you go through. So let's talk about what historically has happened in development. So the way that developers coded traditionally, I would say traditionally a lot of people still do it, but if we look historically it was more common. The standard process was we design a piece of software fully, kind of like the way you build a house. You get your plans with where every bolt's going to go. We develop the software, then we go to test, and then test finds a few issues. They send it back to development, and then theoretically it goes out the door. The way we've traditionally integrated security is we've said, we'll talk to you when you first start to do your design about the policies and procedures, and then we'll come back 2 years later when you're done. And a lot of times it's that call you get on Tuesday when the developer calls you and says, hey, we want to go live on Friday. Would that be cool? And everybody's had that. So then you in a panic, do all the things you want to do. You do static analysis, dynamic analysis, pen testing, reviews, whatever it is you need to do to say, no, you can't go live, go fix your stuff. And then you go live, and ideally you monitor in production. So that was kind of the theory. So by the way, this was my little testy thing, my little sensor thing down here was this little tricorder. If you watch Star Trek. Here's the problem with waterfall development. And so I was a developer for about 20 years before I got into security, and then was still a developer for about 7 or 8 more years in security. Here's the problem with waterfall. It was a lie. We lied to you. We knew that we weren't going to ship when we said we were going to ship. And it's funny, if you've been in the industry, this is a really, really old cartoon from the development world. And it kind of outlines the fundamental problem with waterfall development. The problem is that people are involved and communications tend to be horrible. So literally, if you were an old developer like me, or middle-aged developer like me, I can show you this graphic, and you've honestly probably seen it your entire career. And it basically mocks the fact that what the customer tells us we want is not what they actually want as a developer. What project leaders then come to the developers and tell to build is not what you're supposed to build. So they're using the irony of a simple swing. Engineers typically then grossly over-design whatever they're supposed to fix or build. It actually gets built in some way that would never be practical, and salespeople say it does way more than it ever does, and we bill the customer obscene amounts of money. And this is what we actually wanted to build. Is my mouse working over there? Yeah, good. Okay. So what's funny about this is that it worked in every development shop. I could show this to any developer and they go, yeah, that's pretty much true. So the theory of Agile was, let's stop doing that. So what I want to talk about is the central tenets of Agile, so what your developers do. And I've heard security people say, well, Agile just means they don't plan. That is absolutely wrong. Agile simply means you plan as much as you practically can to do the thing that needs to happen next. Okay? It's much more like flying an airplane than building a house. When you take off on an airplane, you know you're going to New York, and you point the airplane toward New York. But everywhere along the way, you're asking, where are we? Where's the wind? What's happening? And you change as you go along. It's much more like that. So here's the central tenets of Agile, and I want to talk about how that affects security. So first rule of Agile, we value individual interactions over processes and tools. Doesn't mean processes and tools are bad. It simply means we value individuals and interactions more. So what that means is if there's a document that says we're going to build and you and I are talking, I care more about you than I do that document. If you're the customer and you say you want it to be pink and not blue, it's going to be pink and not blue, even if the document said it's going to be blue. Okay? I value people over processes. Not that processes are bad, but simply I value people more. We value working software over comprehensive documentation. The concept here is I'm going to build something that works, and I would like to document it, but I'm going to build something that works. So from a security perspective, the challenge there is if you're relying on documentation, you're relying on security processes and procedures, you need to know that your developers value the software over the documents. So you need to get into their stream, and we'll talk about that. They value customer collaboration over contract negotiation. Again, I'm going to work with my customer to build what they want, not so much worry about the contract. So if security is only in the contract, you have a problem. You need to be involved in those conversations. We respond to change over following a plan. Simply means we're going to build what the customer wants, even if they didn't know what they wanted when they started. We're going to head where they want to go. So let's talk about an Agile example, how it actually works in practice. And you'll hear, this is just some basic terms. I'm going to use these terms because the next thing I'm going to do is talk to you about how does security get injected into this process. So some of the common terms, and I'm going to take a really simple example and walk through this. First term we have is a backlog. A backlog simply means it's a list of stuff we have to do to build the thing we're going to build. So security needs to be part of this. So this conversation happens really early in the development life cycle. It's where a group of developers go, what are we doing and what does it take to get there? And it's big high-level things. So in this case, for example, we're going to build a swing. So what do I have to do to build a swing? Got to find the location, got to make sure the location works, got to decide on sports system, got to purchase the sports system, and we got to do all the stuff to buy a swing. We then say, okay, let's take a finite amount of work and do an amount of work that we can actually achieve to head us toward our goal. And we call that a scrum. A scrum typically lasts between 1 to 4 weeks. The theory is I'm going to define something, I'm going to build it, test it, and be done with it. If this were a website, I'm going to build and test and be done with 5 pages or 3 pages or whatever the amount of work is. In our case of our swing, we say, okay, we're going to find our location, we're going to test our location. Then, very important, we show our customer and review what went wrong. I'm going to go to the customer and say, do you like this tree? And Billy's going to go, no, I don't like that tree. There's a big dog next door. Okay, let's go find another tree. Okay, so I'm going to find a tree first. But I'm going to do a finite amount of work. Next scrum, I'm going to come along and say, okay, let's hang a rope up. Let's make sure Billy likes the rope. Is the rope in the right place? Maybe Billy comes up and says, hey, I like that rope because it's really long and I could tie my cat's tail to it and swing the cat. And you go, no, got to make the rope shorter. So you're going to make corrections. But we want to get that rope done. We then hang the swing and we're done. The challenge with this is, imagine security is concerned with the safety of the branch. If you come along when we have this on the right-hand side, the swing is ready, and say, oh, by the way, that branch is wrong. This swing is going live. Billy is swinging in the swing. You are too late to the dance. That's what happens to security. We go to the development team when they're ready to ship, and we are used to waterfall processes where that first time we went to test, we knew we were going to be redeveloping. In this case, it's going to ship. The software is shipping. So This is what that looks like in a more formal thing if you're not building a swing. The typical process you'll see is these little squirrely marks. It basically says we go into our Agile process, we discover software, we decide what we're going to build, we design it, we develop it, we test it, we talk to our users and let the users say, yep, I accept this. That is a finished piece of work. Now we go to the next phase. We build the first 5 pages of the website, now we go to the next 5 pages of the website. When we get to this point in the process, and this is where security a lot of times gets involved, and here's the killer for you. When you get to this point, this is not software that's going to go back to development. It's gold. It's shipping. It's actually going live, and it's actually a product. If you're getting involved way down here, you're dead. It won't work. You're going to have to delay a release, and it's on you, not on anybody else. So you've got to get involved in the stream much earlier in the process. The way that we do that, and this is what a lot of times looks like, is you have your backlog, which is just a list of things. We want to take the technologies, the methodologies, the activities that we want developers to do, and we put them in the backlog. A lot of times these will be called, depending on how you're implementing Agile, those are called user stories. A user story is simply a thing you want done. And you'll see these phrases that will say, as Billy, I want a swing that I can swing on. And that format of as, whatever the person's name is, what do you want? It's not a design, it's a statement of desire. I want this thing. Why do I want this thing? So your user roles are going to be things like as security. I want to ensure that applications are coded properly, so we need to do static analysis with every iteration of our development cycle, or whatever the technology or methodology you're going to use is. You put it in the backlog. That means you need to be part of those teams. Okay? That means you get involved early in the process and sit down with the developers. I've worked with a number of companies where I was working with the development teams, and literally I've heard the developers say, the security team's really nice, we like them. They were here last year. This is a team of people who build software every 2 weeks. They hadn't seen their security people in a year. So you've got to become part of that team. That Scrum team of people that build this thing is basically their ecosystem. It's their world. So if you're not integrating with it early, which the way you do that is you get involved with a backlog, you put your task in there, and then when somebody wants to go, what does it mean to do static analysis? Your name's on it. And they go, hey Jim, what's static analysis? We'd like to do that. And then you can help them, or pen testing, or whatever the activity is. That security task thing gets put in the backlog. Sometimes those backlog items are single tasks, like you may want them to do a threat model. Maybe a single thing you have them do. It may be something you ask them to do with every iteration. So static analysis, dynamic analysis, whatever it is thing you want them to do. You're going to inject that as a user story that gets put into every Scrum. The theory of that is, and what you need to ask yourself as a security team is this an activity which can occur once and be sufficient? For a threat model, that may make sense if you have a good enough architecture. Some activities, though, you want them to do on every piece of code, and remembering that they're building code, testing code, and having releasable code at the end of that process. So if I'm building 5 web pages, you want me to test those 5 web pages. You need to make that with every Scrum cycle. Now, those may be little bitty tests. It may be static analysis where only 5 things change, so you don't get many results. You don't get many. They don't have to deal with much. It's very consumable, as opposed to scanning at the end of a process and killing them with results. So the activity needs to be integrated. And you need to kind of think about, is this a one-time thing or is this an every Scrum thing? Another thing to keep in mind is at the end of these Scrum cycles, one of the concepts of Agile is that at the end of every Scrum, we have what's called potentially shippable software. That means at the end of every Scrum, if the business came to us and said, we are dying, we've got to have something, you could ship it. So being integrated into those Scrum cycles becomes very important because every time they build and get to the end of these Scrums, in theory, they think they can go live. So if you're not integrated, you're going to have a lot of pain. Some of the tools of the trade, we talked about this a little bit, and this is just a simple list. There's obviously different approaches to application security. Some of the things that we typically want to integrate into the process are things like threat modeling, static analysis, dynamic penetration testing, peer review of code. There are other activities out there. If you go look at like OpenSAM or BSIM, there's lots of lists out there of things you can do. The trick with each of these is to understand what is it, how much does it cost, is it something that's practical to integrate? And then decide, is this something we do once or something we do repeated? Or for some applications, is it something that we even do at all? So for example, if you have a marketing website, you may not do a penetration test because the cost of it is just too high. Or if it's only internally facing. But that's something you've got to decide as a security team. based on the risk of the application and your budgets, realistically. You can't do everything with every application. So do things on purpose. Decide based on risk, and I'll post this slide if you guys want it. So basically saying, based on risk, I'm going to choose the activities I do, and I'm going to choose if I do them once or if they are done repeatedly throughout each of these Scrum cycles. And again, typically that's based on cost and the value you get. I'm a huge proponent of penetration testing. I think it brings huge amounts of value, especially if the tester is good. I also know that, in my experience, somewhere between 2 to 5% of all applications that companies have are actually pen tested. I spent about 4 or 5 years one time asking that question of every single customer I talked to, and that was kind of their number. And it's cost. You know, if you build a $5,000 website and it costs 20 grand to pen test it, you probably don't do it. If you're building a banking website, you're probably going to pen test it. So you've got to decide where that goes from a budget perspective. Also from a time perspective. Another thing I would keep in mind is activities that typically security is owned, and especially static and dynamic analysis are things that I do a lot with, or even how to peer review. You've got to ask yourself the question of who owns the task and who monitors the task. What I mean by that is if security comes and does the test, the static analysis, for example, we just use that as our example. If they do the static analysis test, if you guys want to do it with every application, with every Scrum, and there's 100 teams, and they build every 2 weeks, you just got a retirement plan. You're going to be busy for that with the rest of your career. You can't scale that much. It's just impossible. Where I've had a lot of success with companies, and I can almost tell you in the first week if I'm going to be successful or fail when I'm working with companies, if the development team owns that, so if they go, oh, we like static analysis, we understand that, we're going to own that. We understand dynamic analysis, and the QA testers figure out how to execute those tasks. Or code peer reviews if they actually get educated. If the development team owns it, and as security, you've become coaches, you've become mentors, you've become standard setters, you're probably going to be successful. If, on the other hand, you're saying, no, I'm going to run the scans, and I'm going to do the test, and I'm going to go tell you what your vulnerabilities are, and I'll give you a PDF at the end of that, you're probably going to fail. Because you're not in their food chain. You're not in their stream of things they do on a daily basis. And Scrum is very much about, Scrum and Agile are very much about, give me 2 seconds, very much about staying hyper-focused. I'm going to build these 5 web pages. All else goes away. Now, at the end of building those 5 web pages, we do what's called a reflection. That's where we kind of look at. We put our head up and go, okay, where are we at? What's going right? What's going wrong? Where are we at? But then we go back in our cave and build our code again. If you're not in that process with them, or if your technologies and methodologies aren't in their process, you're going to hurt because they're not paying attention to you while they build. So you've got to let the developers own it. I know some security people will fight me on that one. I respect that, but I've just seen it. You're outnumbered. We're outnumbered. The facts are. There's a little bitty room here full of people and thousands of developers out there. So you've got to get them on your team. Question?
I agree with you. However, there's an additional challenge when your developers are outsourced, third parties.
Yes.
That's
actually a great question. Thank you. So the question was, if you have third-party developers, obviously you don't directly control them. That becomes a really big issue if you're dealing with developers like overseas. You've got time zone, language challenges, just communications is a challenge. Where I've seen it work well, a lot of times companies will have a small team of developers that are US-based, and then a big team that are external. And you really start to rely on that US-based team. So they're going to make sure that the scans are run, or whatever things need to happen, they're going to own that. A challenge you run into, too, is that a lot of times your outsourcers, you don't have consistent teams. Just, this team builds this widget, and that team builds that widget, and you can't train them.
Turnover rate, all sorts of
Yeah, that's what it is. It's hard. So honestly, it's hard. It certainly complex. It makes things more complex. What's worked well with companies I worked is where the team that was locally based, whatever was local was, that team owns it. That's the team you're working with on a daily basis. Typically, your Scrum Master, so the Scrum Master is the Agile version of a project manager. They own that backlog and the list and what gets built. They own that. That's the Scrum Master's job. What we typically would have called project management. So it's a little different. You typically want the Scrum Master involved, and there's usually an architect, team lead kind of person. Those 2 people you really want to have involved. And then they'll choose who else. But yeah, outsourcing is a challenge. What I would strongly suggest against is allowing code to go be developed somewhere, and this is where you're burnt. When code comes back in, there's usually an acceptance criteria, and what I usually work is with whoever does that acceptance, again, it's the team lead and the Scrum Master usually, get those folks involved and make sure that they're doing that testing prior to accepting the code. And usually if we look at Agile, kind of around here at the end of it, So what's going to happen is in the last sort of quarter of the scrum, so if you're on a 2-week scrum, it's like Wednesday to Thursday typically. What commonly will happen is Tuesday night they'll put a build in. Wednesday night, Thursday, you're doing most of your user acceptance testing, reviews, reflection, kind of going, did we build it what we said we were going to build? What messed up? Where are bugs? Where are defects? What do we got to do next time? They're planning their next scrum out. If you can get hooked in that portion of the phase, that helps a lot. Now, some testing also takes a while. So with outsourcers, it gets a little worse. Some testing takes a little while. So, for example, if you need to do a penetration test, that takes 3, 4, 5 days, 2 weeks. What you've got to remember as security is that those defects that you give them are going to go in the next scrum down the road. So you kind of have to mentally start thinking, okay, if I get the results back next Tuesday, I know the next scrum doesn't start for 2 weeks, and then that means they can fix them. And so that kind of gives you a realistic timeline of when you think you're going to get these fixes back. But yeah, integrating with outsourcers can be a little bit of a challenge. So certainly makes things a little bit more complex. Good. Okay. Let me walk you through a real-world example. We've got about 15 minutes left, ish, 15, 25 minutes, 20 minutes left. What I want to do is walk you through a real-world example and walk through the process I went through for implementing a application security program in an Agile development lifecycle. The first thing I started out by doing was creating a big, huge mind map. This is a lot of stuff on it, and quite honestly, when I show this to managers, I typically shrink everything down a lot because it'll overwhelm them. So I kind of broke it down, and I'll zoom in and move around a little bit, and this is all live, which means something's going to go horribly wrong here in a second. If you've ever presented, never do things live. So things just go horrible. Demos especially. So basically what I said was, let's break down all the activities that we need to do. And I kind of went through this process and said, okay, what's the first thing we've got to do? Well, we need to go through a program creation, which simply means we're going to define what we do. So what are the things that I expect our developers to do? What are the technologies that they're going to use? What are the methodologies they're going to use? What are our expectations? And I want to communicate that to the development teams very, very, very thoroughly up front. So first thing we went through is did a program creation process. We then went through and defined what are the activities that we want development to do. So this wasn't that development was supposed to go check a box. It's here are the activities we need you to do on a consistent basis as we go through development. I then went through the process of articulating which of those things, and if you notice I've got some of these have this little cycle here, which of these things are done in every scrum. So every time you go through your 2-week scrums, we want you to do static analysis. That was one of the things we wanted them to do. We wanted them to do an architecture review. Now, this was not a huge CAB committee, 20 people, scheduled at every Tuesday review. This was lead developer, scrum master, and whoever was making an architectural change, sitting down in a room for 15 minutes and going, okay, what would we change? Did we touch authentication? Did we touch authorization? Did we, and we also made a list, by the way, of things that caused us heartburn. So, for example, how you do logging, we decided that was really important. We wanted to have logs for events. We would really like to know if your application's under attack. So if you've worked in the web app firewall, IDS world for a while, you'll know that the better your applications are, the harder it is to know that they're under attack. Here's the reason. Most SIEMs take logs. Logs are generated when things like system errors occur, 500 errors occur in your application. As you code more effectively, you get less of those because you do input validation, you code things properly, your applications crash less. When they crash less, you get less logs. When you get less logs, your SIEM becomes more blind. So we talked very intentionally to our developers and said, hey, if you see somebody SQL injecting, let's log that. We know you're not going to crash over it, let's log it. If you see strings coming in and parameters that are supposed to be integers, don't just filter it, actually throw an error because that's maybe somebody being a bad person. So we talked to them about logging. We talked to them about how they do authentication, authorization, password resets, all the normal things. We talked to them about encryption. Basically, if you don't have a PhD, you don't get to do encryption. You have to use the standard libraries. So it was kind of this discussion. So when they go into their architecture reviews, they're asking questions. Did we mess with authentication and authorization? Did we mess with logging? Should we be logging? They asked this kind of a basic series of questions. 15-minute meeting. If they haven't changed anything critical, no big deal, they move on. But they've done it. It was in their backlog. It was an activity that got completed. They move on. But it becomes a very habitual thing. And it makes them think about what's the architecture we were supposed to build to, how do we do that? It doesn't take a lot of time. We also looked at if they're going to do threat modeling. Really, we tied this one in with architecture, quite honestly, really looking at trust boundaries and how we pass data around. Other things that we talked about were single tasks, like libraries and embedded code. We said, okay, what kind of libraries do we accept? What do we not accept? How do we do peer reviews? We also then had QA testing. The QA testing also went beyond just traditional QA testers. We wanted them to also own not necessarily the act of doing penetration testing. We wanted them to trigger the event of a penetration test. So there are a couple of systems that we were working with that were PCI related. We knew before they went live we had to do a pen test on them. So we said, okay, and we explained what penetration testing was, and we said, understand you'll have to do this before you go live. Put into your workflow that you need to do it, and know that you're going to need about a 2 or 3 week window of time to get the pen test done, to get the results back, and mitigate the issues. So they knew, okay, 4 weeks before we go live, whichever Scrum that is, I need to throw this in my backlog. And put it in the backlog and know I've got to do it. So they didn't own the task, they owned the trigger of it, if that makes sense. So they were the guys that went, hey, we need a pen test. No longer does security do that. Security simply says, you want to go live? Great, where's your pen test? Have you requested from us and executed and mitigated your pen test? In our case, they were also doing the dynamic analysis portion. Pre-production security, so this one, I'm going to come back to this in just a second. I've got a reason for it. Yes? In this case, we were outsourcing it. They didn't have a proper penetration testing team, so we were outsourcing it to different vendors. We were kind of using a rotation of vendors. We're heading more toward using bug crowd type environments. What they were doing before, and what I liked is they were switching out their pen testing company that they would test with. They had a group of 4 or 5 companies that they trusted, and they would kind of round robin it around those. The theory being that if the same pen tester tests the same application every year, you get the same result. So we wanted to get fresh views. We've kind of gone to crowdsourcing, a mix of crowdsourcing and traditional pen testing, because some of the pen tests we have to do a lot. So. The cost gets very prohibitive. So that's where some of them, if they were in active development, like there's a core system that does encryption and tokenization of credit cards, we're kind of moving to more of a bug crowd type, where basically there's a bug bounty out there that says this system's in QA, kill it. And if anybody finds something, they report it to us. Pretty good success with that too. So, but then sometimes we still have to do a full-on pen test at the end. But again, the cost of that's very high, so it's not a lot of systems undergo that kind of scrutiny. Yeah, it's a couple of weeks. I mean, typically on average. But so that's something you really have to think about and schedule, especially if you're trying to go live. I'm going to come back to what we did in pre-production because there's a slide that I'll talk about in just a second of where we're heading, and this should terrify everybody in the room where this industry is kind of going. So we'll skip for just a second. Operational security. Again, we talked here about what are the things we're going to do in production to defend our applications, because recognizing that well-developed applications tend to have less events that you can monitor. We wanted to make sure that the logging that the developers were doing was getting communicated in a production document over to the operations team, basically the SIM team, saying, hey, here's the events that we generate. You should go monitor these because something bad. If we see SQL injecting, here's what the log looks like. And so that way the SIM team could go ahead and start integrating that in. Again, this became an Agile question because they needed to communicate every time they did that. So at the end of a Scrum, they'll send a little email over to the SIM team saying, hey, by the way, you're going to get this application in 3 months. Here's what the logs are going to look like. And they can go ahead and put it in. Because the go-live time when something is Agile tends to be very short. Vendor management, this one becomes another challenging one. Really, Agile isn't affected by this, but the vendor management, we can talk about that as a separate presentation. We also added this role, and because we didn't know what to call it, we called it a secure SDLC program manager. This is basically a person whose job it is. They sit with development. I've done this myself with a bunch of customers. The customer gave me a chair in the security team, and I said, can you please give me one over with the developers? This is a person who sits with the developers. They work for security. Their job is to be in the Scrum meetings. They should know what the release schedules are better than the Scrum Masters. And they should have a good view of it. They want to know what's being built, what's being released, what's the release cycle, and are we doing the things that need to be done to make this program successful. Even though they'll work for security, they're going to live and breathe with development. They need to be part of the team. I've had really good luck taking developers and training them into this role. They're not necessarily security experts. In the context, they probably aren't the people you would have do a pen test, but they understand what security needs to have done, not necessarily how to do it all, but they understand what needs to be done, and they're sitting with the developers, and they're doing things like maintaining an application inventory. What's being built, what's in production. So we want to know where are we at. They want to know who owns it. They want to be able to help developers identify risk. They're doing a lot of training type work. And equally important, they're always going to be on these Scrum teams. So whenever that team meets every 2 weeks, they're going to sit down with them and know what's being built.
I would imagine the level of accountability for that position is very challenging. Obviously, you don't want to crush them if something gets through.
Right.
But at the same time, you need them to have solid integrity and backbone.
Yep.
Stand up to the rest of the team. It's something really important.
Right. Yeah, so good question. So basically, how do you balance them being a team member with also having the big stick, basically? What we did is we took it more as a coaching. Their role is a champion and a coach. So when they go into a meeting, their intention is, look, we're going to have to go through a security test at the end of this. So there's going to be a review board, and they're going to demand that we have these artifacts done. We're going to have to have done static and dynamic and some pen testing if that's appropriate, or we're going to have to show them a threat model and explain it and know what we're talking about. Let me help you get through that. So they become the carrot, not the stick so much. The stick is the end of the process, going to a customer, an advisory board and saying, here's what we've done. Have we followed the process? So security, typically people that are more on the operational security side, they're basically going to own this thing that we've built. They're going to sit there and go, have you done all the things you're supposed to do? They don't care how it got done. They just care that it was done. That person, the security SDLC manager, would go there with the security, with that development group to present with them of what's happened. So they're much more of a champion. Now, if somebody wants to cut corners, because you get these arguments of somebody saying, well, SQL injection is not that bad. They do have to be, a little bit of a politician. You have to call somebody's baby ugly and let them say thank you. It is a political job, so you don't want somebody that's, has no social grace, I guess would be the statement.
I agree. We've had one case where we didn't have the resources. We dealt with single code process and technology.
Mm-hmm. Yeah. Yeah, you want somebody, and that's why I like to draft developers, honestly. Find a developer who maybe is looking for a known job, they're a little antsy, you go, hey, application security is cool, train them up. And that career-wise, that helps them. It's a great field to be in. It's insane. So. If I knew I would train them, I would hire them. I would steal them from you. You have to train them. Believe you have to train. I've had good luck again. I like Scrum Masters. So typically a Scrum Master has a significant amount of development experience. They're good coders. And they've probably gone into being a Scrum Master because they wanted to grow their field into a more management route. Those people to me are the textbook person. And it really helps their career. I mean, down the road, now they understand security. They can work, it helps them to move into, more senior product management. So it's a great career path for a developer to go through. So developers, go poach developers. That's what I do. Yeah. Yeah, so kind of a security champion. So having So I still like the idea of having a secure SDLC program manager that owns it. It's their job, but then having the security champions like you're talking about is huge. Good. Okay. So we talked a little bit about, integrating, so this is just an example. This is a really ugly, I'm not a graphics guy, by the way, so this is really ugly. So if you go, wow, that's really ugly. Yes, it is. Basically what we're talking about is in each of those scrums, we're going to be integrating in, for example, I'm just using static analysis in my example, but it's all of them work. Let's talk briefly, and I've kind of added this to the talk. I didn't have it in the summary, but it's become a bigger deal with a lot of my customers, so I've added this. Let's talk quickly about DevOps. Who's heard the term DevOps? Who gets nauseous and doesn't sleep at night when they hear DevOps? So the theory behind DevOps is we're going to release like every 4 hours. And as a security person, I go like that, okay? It's like, oh my gosh, you insane? So DevOps basically is Agile taken to a next level. DevOps says we're going to build a finite amount of code. We're going to test that finite amount of code. We're going to do user acceptance testing of it, and then we're going to release it. So no user accept, no CAB, no customer advisory board, nothing going on. To security people, and to first time I heard that, honestly, at the first I was like, no, you don't really mean you're going to go live. And then I worked with customers who were like, no, we go live. Every day we go live. We ship every single day, which made me a little nauseous. So we had to deal with it and read a lot of stuff, talked to different people, and sort of what seems to be evolving, if you will, as the way to deal with DevOps. There's two things you're doing for DevOps. One is you're integrating earlier in the software development lifecycle. So just like Agile, you're integrating earlier. But now it's not like a thing that's convenient to do. It's like you're dead if you don't do it. They're not even going to talk to you as security if they're going live. You're not going to be consulted. They're going live. So as security, what you've got to do is get them doing the things you need. So the things we talked about with Agile, doing their testing as part of that sprint, becoming part of the testing. Now the good news is when you have DevOps, typically they focus extremely heavily on automated testing. You do not write code that can't be tested in an automated fashion, period. As a developer, that's like a general rule. Because if you can't test it, you can't ship it. So it becomes a militant subscription to you must be able to test this in an automated fashion, which from a security perspective is nice. It means that there's automated processes in place and the code is generally testable. So we can generally do a lot of security testing against it in an automated fashion. Now, what we also then need to do is, I think, two things come into play. One is if you're going to do penetration testing, you're just going to have to do it on a cyclic basis when it makes sense. If they do something interesting, change authentication, for example, let's do a pen test. But it becomes more of an ongoing practice. That's where I think some of the bug crowd kind of stuff works. Also, so they're integrating security into their process. So they're doing automated testing to the extent possible. You're doing manual testing, penetration testing periodically. The third thing I think that becomes really critical, and after just talking to folks, this seems to be where the industry is going, is the applications need to be able to notify you when they're under attack. They need to be able to tell the world, we're being SQL injected, go deal with this. That needs to tell your SIM, your system, so that you can deal with it. Here's the basic theory. If I write a piece of code today that's SQL injectable, and I'm a DevOps shop and I put it into production, it's out in production. We now have a production SQL injection vulnerability. When somebody goes to exploit you, they're probably going to poke around all over the application looking for a mistake. And eventually they'll find my hole that I just wrote and go exploit you. You really need to be able to detect that you're under attack generally, so that when a general attack is occurring, you can defend against the attack as a holistically, for example, blocking their IP, blocking their session, logging them out, dealing with it in some way before the attacker finds the hole. So the theory being, we still need to find the hole, but you're going to go to production with a few of them, which stinks. But know when you're under attack, have your applications detect when they're under attack, which you can do by coding good logs, dealing with events, dealing with different types of attacks. There's also technologies out there like RASP that will help you detect that. But detect that you're under attack and block before the attacker has time to go find the vulnerability. And then also make sure you're finding that vulnerability as quick as you can. You get it back into the next sprint and get it into production as quick as possible. So DevOps as a technique of development is a little bit terrifying, quite honestly. But it really means you need to be integrated heavily into the process. There's a couple great articles out there. If you send me an email, I'll send you a link to these. They're some of the DevOps group are talking about how they deal with security. A couple things they do, they look at activities as blocking and non-blocking. They have this first concept, and this is this pre-production security review. This really deals with DevOps. The first thing they're doing is they say if you do certain activities, for example, where you change encryption, change authentication, that's going to trigger a review board. So while DevOps lets you go live every day if you want to, there are certain things that are going to trigger a review. And that review needs to happen early. So if during this beginning of the Scrum they realize they're going to change authentication, they need to notify the review board, hey, we're changing something critical, you need to look at this before we go live. That's their job as developers to notify. So there is a review board, that's a blocking change. Meaning if the review board says, no, you did it wrong, it doesn't go live. So that you can still block. The next thing that's typically done is if a penetration test were required for the release, for the change, that has to happen before you go live. Obviously, pen tests take a while. So a good penetration test is going to take some time, so they're going to have to budget that in. But if they're doing credit card stuff, deal with it. And then you have other things that are called would be non-blocking. This is where security is looking at the releases that go out, but they're not blocking the release. They're simply looking at them as they go out, and if something bad has happened, they go back to the development team, get a defect logged in their backlog to fix it, and then they get fixed the next cycle out. So, and generally the idea is that we're going to have generally more secure software. It's not going to be perfect, but that's more of a business risk. So DevOps is a bit of a challenge. But being integrated into the process is your only hope. If you're not, you're going to get burned. So, we've got just a couple minutes. Any questions before we stop? I know lunch is next, and we have hungry people walking this way. Y'all can come in if you want, by the way. Question?
I was going to comment on the automated testing. So basically, it's based on off-the tools called automated. That purpose. No source tool.
Oh, cool.
That's designed to automatically test an application.
Where can people find it? OWASP or?
It's not an OWASP tool. It's called Gauntlet.
Gauntlet? Okay. Okay, it's on GitHub. So it's called Gauntlet. If anybody didn't hear, it's for automated testing. Good. Any other questions? Yes. Questions? Yes. It is. So personally I like RASPs. The reason the challenge has always been with a WAF is that a WAF has to learn what the application is. So for example, if I've got a parameter that's an integer and it has to learn that that's an integer value, and if I see a string coming into it, that's not appropriate. RASP have the advantage that, especially in .NET and Java, that they can use reflection to determine that. So if they see a string come in, they know that that thing's an integer. They know the nature of the application. If somebody just throws in garbage parameters that don't exist, they're going to know that because they can see the objects that are supposed to come in. I think that's just a competitive advantage. They're more palatable because I can integrate my RASP into my testing cycles, so I know the application will run with it when it goes to production, as opposed to WAFs, which typically are just introduced in production. I think the technology has a lot of promise. Honestly, I want to see more tests done, but technically, as a concept, I like the concept a lot.
What about, so my thought was really adding it into SDLC, where you do things like static analysis.
Right, for configuration and known vulnerabilities, those kinds of things. I like that. I think that probably applies to WAFs and RASP. I think it probably applies to both of those. If I know I have cross-site request forgery, I can block it with either tool. I think it's probably a little bit easier with a RASP. But yeah, I like the whole idea of taking the existence of a vulnerability and blocking it, and then once you fixed it, remove the block. I think technically is a good idea. Yeah. Yeah. Yeah, the more rules you have, the slower things get and the more heartburn is. So I like the fact that it can be tested a lot. So technically, I've got a couple customers that are installing. I'm going to be doing that over the next few months to play with them. We're going to do a bunch of load testing against them just to see. But so far, it looks good. So far, I'm positive. All right, cool. It's 10:45. If you guys have any questions, email me. I'm going to leave fairly quickly out of this. My son is graduating from the Army Combat Medic course, so I'm just a little proud of that one. So, yay, Jake, my son. So I'm going to head down to Texas or to San Antonio and watch him graduate. So if you have any questions, feel free to email me. I think I've got my email address here. You guys are welcome to email with any questions. Dennis.Hurst@saltworksecurity.com. Great, thanks. I think our lunch is starting. If you guys want to go grab food too, you're welcome to.